I am going to loosen this nut by using a wrench. uh, so this is wrench. We with my fingers, it's not possible to rotate this nut because my fingers cannot produce enough torque to rotate it. But by using this wrench, I can do that. So I'm going to also use a dynamometer. So I want you to calculate how much torque is able to rotate that nut. So normally there's friction force between this nut and this plastic, I mean the object. So this friction force, as I try to rotate it, this friction force is also producing oppositely directed torque. So maybe you remember from the 11th grade that when you try to push an object on a surface, like an object, so this object, it's not easy to pull this object because there is the friction force between the surface and the object. And remember, when you pull with 5 newtons, so if it is not moving, which means static friction is in the opposite direction, and 5 newton. For example, if you are pulling with 6 newton, if it is not moving, so which means static friction is 6 newton. If you are pulling with 8 newton, if it is not moving, static friction is 8 newton. So which means until it starts moving, with what force you are pulling the object, so static friction becomes the same value of that force. But static friction can get a maximum value, so it cannot be greater than that maximum value. When you start pulling this object with a force greater than maximum value of the static friction force, so then you are going to see that object starts moving. So static friction force is not a constant force, as I explained. So it's changing according to the force you applied. But if it can get a maximum value, if you pull an object with a force greater than that maximum value of the static friction force, so then you are able to rotate, you are able to move the object. In fact, it is similar in here. Between this nut and this plastic platform, there is a static friction force when you try to rotate it. So this static friction force also produces a torque in the opposite direction. That's why I am unable to rotate this nut. But if I don't try to rotate this nut, if I don't apply a force on this nut, of course, there will be no static friction force. There will be no torque produced by this static friction force. Now, I am going to show to you that first, let me get the distance. What is distance for this range from axis of rotation? This point is the axis of rotation, so we are trying to rotate. And then length of this, length until here, because I'm going to apply the force right here. So that distance is almost 14 centimeter. Yeah, 14 centimeter. So then I'm going to apply a force at is it 14? Yeah, 14 is okay. At a distance of 14 centimeter, and I'm going to try to rotate it. Now, I connected dynamometer, so I want you to read the force, how much force I am reading, because here is the scale, 0, 1, 2, 3, 4, 5, and so on. So 14 centimeters is 0.14 meter, you know. So I'm going to apply the force perpendicularly. So now I'm applying with a force of 1 Newton, 2 Newtons, 3, 4, 5, still it's not rotating, 6, 7. When it starts, it becomes 7, so then it starts rotating, which means now I can calculate how much force, how much torque is needed to rotate this nut. So 7 Newton I applied by dynamometer. I observed that when it was 7, it started rotating. So distance from where the force is applied till the axis of rotation was 0.14. So now I'm going to use my calculator. The force is 7 Newton, which I applied, multiplied by distance from force to the axis of rotation 0.14, which is equal to 0.98. 0.98 Newton meter torque is required to rotate this nut. So required torque for rotating this nut is 0.98 Newton meter. If it is less than that, it's impossible to rotate that. You should first catch that torque. You should, of course, attain that torque. So then when it exceeds that number, so then this nut will start rotating. So this is what required torque is. We need a minimum number of torque, minimum amount of torque to rotate any object. It can be a nut, it can be a door. For example, to rotate the door also you need to rotate a minimum amount of the torque, or to rotate the handle. You know, handles also not so easy to rotate. Sometimes you need sometimes children cannot open the handle because they cannot produce enough torque on the handle of the door. So then you also need a minimum number of torque, amount of the torque to rotate the handle, or it can be a window. So which means in general, the minimum amount of torque required to rotate an object is we define as required torque. This is the case. When you try to rotate a nut, torque, you apply a force with your hand. This force produces a torque. The torque of a force applied by a specific source, it can be your hand, can be any source, at specific direction, at specific magnitude, is called applied torque. So this is what you apply with your hand. But in reality, there are other forces such as air resistance and friction. Air resistance we don't care so much, but friction, static friction, which produces counteracting torques, which means counteracting torque means opposite directions. In the opposite direction of the torque applied by your hand, so then friction force produces an oppositely directed torque, which is called counteracting torque. So then if the applied torque is equal to the counteracting torque, so then, or the maximum value of the counteracting torque, which means object is ready to rotate. But if the applied torque by your hand is a little greater than this counteracting torque, object will start rotating. So we are going to study this part. When applied torque is equal to maximum value of this counteracting torque, maximum value of this torque produced by the friction force, object is ready to rotate. But when you exceed that number, very small number, so object will start rotating. Even object will start accelerating. We are going to start in section 3, this part in details. So then definition of the required torque is this: the minimum amount of applied torque that starts rotation on object is defined as required torque. The minimum amount of applied torque that starts rotation of an object is defined as required torque. This definition is not given in your book. Just I want you to make your main clear about what required torque is. But most probably, don't worry, they will not ask this definition to you because it's not defined in this way in the book. Just questions and problems are given. So, but definition maybe can make you understand the problems much easier. So the minimum amount of the torque that starts rotation on object is defined as required torque. So the required torque to start rotation of object is a constant number, such as, for example, I gave some random numbers. A nut can be loosened by 100 Newton meter torque, for example, or a door can be opened by 5 Newton meter, for example. For example, a bicycle can be rotated by 25 Newton meter. For every different object, that minimum amount of torque to rotate that object is different. So every object can be rotated with a different number of the minimum number of the amount of the torque. So for every different object to start rotation, you can need a different amount of torque. So required torque for different object can be different. So any questions about required torque? What does it mean? Did you get it?
Teacher, I'm sorry, but my electricity got cut off. Can you briefly explain what applied force and counteracting? Applied torque and counteracting torque is?
Applied torque is what your hand produces. A counteracting torque is the torque produced by the friction force. So that's why always you are not able to rotate an object. You need to, for example, as I showed, did you see the experiment that I showed you with the wrench?
Yes, teacher.
Normally when I was trying to rotate it, so then it's not easy. It doesn't start rotating as soon as I apply a force. For example, right now, so I am pulling with 2 newtons, but not rotating. So which means friction also produces oppositely directed torque. Even you can calculate it now. 0.14 meter is the distance multiplied by 2, 0.28. So applied torque is 0.28, and then friction force also produces a counteracting torque, which is 0.28. So sum of them is 0. It's not rotating. Now I increase the applied torque. Friction also increases its torque, but friction can get a maximum value. So when I produce a torque greater than that maximum value of the counteracting torque, and this nut starts rotating. It is the rule. So then friction cannot produce an infinite amount of torque, so it can have a maximum value. When your applied torque by your hand is greater than the maximum value of the friction for torque produced by the friction force, so then object starts rotating, and this value which of applied torque, which starts the rotation of an object, we are going to say it is the required torque, and this required torque is different for every different object. For this nut, for example, we calculated when I tightened very strongly, so it was 0.98. For a door, for a window, for a bicycle wheel, for something you rotate on your life. So everything has a different number of required torque. So this number can change from the object to object.
So, teacher, we can see an example of counteracting torque is friction force?
Yes, friction is in our life. I mean, air resistance is not so frequently we met, but friction, yes, static friction especially, because it's not, it stops object to move. That's why static friction force produces those counteracting torques.
So counteracting force is opposing our, for
yes,
example.
opposing. That's why we are saying counteracting.
Yes.
Opposite direction.
So, teacher, the required torque is larger than the counteracting torque?
Must be. A little greater than counteracting, then the object starts rotating. If much greater, what happens? It accelerates. So we will study in section 3.
Teacher, why did you say counteracting force can't, you didn't say can't be bigger than applied force, but why did you say it's wrong? Is there like a reason?
It's impossible. It's impossible. Static friction force can never be greater than the applied force. That's why I realized it, but it was late when I published the document, so it's impossible. Always equal. They can be equal, but counteracting torque, which friction force can produce a maximum amount of torque, so it cannot be greater than that value. So when you produce greater than that value, so an object starts rotating, that value is called required torque.
Yes, so when applied force is equal to counteracting torque, the object doesn't rotate, but it's ready to rotate.
Ready to rotate, but a little greater than that, so it will start rotating, even if it will start accelerating.
Yes. Thank you so much, teacher.
So now there are some questions in your book about this. Yeah, questions?
Sorry. Yeah, in the third case, the counteracting torque will convert to kinetic friction, right?
Yeah, you are right, because in this case there is a motion. In this case it will be not static friction, it will be kinetic friction force.
But in the second case there is no motion yet, but it's ready to
ready to rotate. That's why I wrote it. Its object is ready to rotate. It's the static friction force is doing that. Then of course I'll start rotating. In this case the force of friction changed to kinetic.
But teacher, is it visibly like stable, like it's not moving, right? In the second case?
Second case, not, I mean you mean this case, huh?
Yeah, in the middle.
Not moving. Ready to rotate. I write it ready to rotate, but not rotating.
Okay, thank you.
Okay, question. There is one problem in your book about required torque, and then it's written that practice problem 2. The torque required to loosen a nut on a wheel of a car has a magnitude of 40 Newton meter. So this is the required torque. This is the minimum amount of torque you should produce to rotate that nut on the wheel. So 40 Newton meter. What minimum force must be exerted by a mechanic, by a man, at the end of 30 centimeter range to loosen that nut? Yeah, in fact, I did this similar example here in demonstration. So the minimum amount of, let's record the things, required torque in here is 40 Newton meter. Let me record it, torque minimum. This is minimum amount of torque to start rotation of that nut, to loosen that nut. This number is constant for that nut. This number doesn't change. 40 Newton meter, you need this. And distance, it's a range. Let me draw a range in here. Range is something like this. My drawing is not so perfect, but I will try to draw it. It's something like this. So here is the nut. Of course, you are going to rotate the nut. The length of the range is the distance where the force is applied. Length of the range, it is 30 centimeter, and you apply a force in here, F. So what minimum force is needed to rotate this nut? So distance is the length of the range. It's given as 30 centimeter, or 0.3 meters is the distance. So calculate the minimum force to loosen that nut. I mean, the calculate minimum number of force. Of course, you should use the equation for torque. Torque minimum is equal to force minimum multiplied by distance multiplied by sine theta. And if you let torque minimum alone, so simplify the sine theta by dividing the sine theta. So the sine theta will simplify on the right side. Force minimum is going to be torque minimum, which is the required torque. It is a constant number, divided by the sine theta. Okay, if you want F minimum, you should make the and sine theta maximum. Sine theta maximum is how much? Maximum sine theta?
90.
90, and it's 1, is it?
Yes.
So which means you should apply the force perpendicular to the distance to apply minimum force. Sine theta must be 1, and D must be as long as possible. D is the longest, which is the length of the range, and it's given in the question as 0.3. You are going to insert the given into the equation, and you will find that minimum force minimum. Torque, required torque is 40. This number never change, so you should first attain this number to start rotation. 40 divided by distance is 0.3 meters, which is the length of the range. It's the maximum length of the range. From here to there, it is this distance. You cannot make longer than that because range is 30 centimeter. Sine theta can maximum 1, so that's why your answer will be 133.3 Newton. So this is the minimum amount of the force you can produce required torque, and you can rotate or loosen this nut. Yes, this is the problem. This is they like to ask in ministry exam, and they are a little change in this type of the question, but same logic. How would the force needed? So it's about required torque. This question is about required torque. How would the force needed change if you put the handle in the middle of the door? Remember, I told you that to rotate the door, to rotate the window, to rotate something, you need a minimum number of torque, which is called required torque. So initially, you put the handle at the end. In here, it is at the end. You need a force F. But if you take the handle from end to the middle, what decreases? Distance? Yes, distance decreases. Initial distance is D, but then distance D over 2. Same torque must be produced. Yani F torque in here is required torque, which is minimum number of torque, F times T. Here also it must be F times T, but what did you do here? You make distance half value, D over 2. If you decrease distance by half, you should increase the force by 2. So then these 2's will simplify. You will get again F times T. As you see, these two values must be equal because you need same number of torque to rotate an object, the same object. So this is, they are frequently asking these types of questions. What if they ask 1/3? How would the force needed changes if you put the handle not in the middle, 1/3 of the door? Yani you are going to take the force somewhere here. So this is the door. So this is, you are going to take the force right here. So it will be d/3.
Our
So what do
force
you-
will be multiplied by
force-
3.
Yeah, 3F, you need 3 times. How many, by what factor distance decreases? Force must increase with that factor. So in here, force decreases, distance decreases by 3, force must increase by 3 to get the same amount of torque. 1/4 olsaydı, if it was 1/4, F, this is d/4.
Increased by 4.
Yeah, increase by 4. This is so simple, but they will ask you again. This problem will be asked by changing these numbers. d/2, d/3, d/4. Frequently, they are changing number and asking this question as a ministry exam question.